And let me try that again. All right, so that looks better. So, all right, y'all. So 9.4, we're going to look at logarithmic functions. So I'm going to give y'all the definition of a logarithm before we start playing with these problems. And y'all, basically a logarithm is an exponent. Okay, now we use this LOG. That's the logarithm notation. All right, so let me show you what I got. So here's the logarithm. This is a subscript. And where I got the X is, that's what we consider the base. So that's the base of the logarithm. The Y right here, the Y is considered the result. And B is the exponent. So if you take the log of a base to get this result, what's going to be found is the exponent that it took to raise X to get Y. Okay, so watch this. Log base X of Y equals B. This arrow means if and only if. X to the B equals Y. So the base is the number being hit by the exponent. B is the exponent and Y is the result. So when you write it as exponential, your base gets hit with an exponent and that's going to give you some number. If we know the base and we know the result, then the logarithm finds the exponent that you had to raise it to get that result. So in the long run, these exponents are nothing. I mean, the logarithms are nothing but exponents. Now, we'll say this on the calculator. If you hit the math button, so I'm going to hit my math button right here. I'm going to arrow down till I find one that says log base. When I hit enter on log base, it'll bring it to the screen. And notice it has the cursor where I would put the base. And once you put that base in, you arrow over and you put the result in. When you hit enter after that, it's going to give you the exponent that makes that true. Okay, so, whoops, someone must have. All right, trying to let Giselle back in. She must have got knocked out. All right, so these examples, I'm going to find the logarithm. So I'm going to start at 4 because this is where these would start out on your homework. And then I'll go back in a little bit and graph the first 3 were graphs, and I'll go back and graph them in a little bit. So this one wants me to find log base 5 of 125. So I'll do this by hand and then I'll show you how I can do that on that calculator, okay? So what I want to know is what exponent would I raise that 5 to? So what exponent would I raise the 5 to for it to equal 125? So that would be what? 5 times 5 is 25. 25 times 5 is 125. So since I did that 3 times, the log base 5 of 125 will equal the exponent of 3. So like I said, we can do that on the calculator. You would hit math, arrow down till you hit log base, hit enter. My base is the 5, so I put my 5 in, I arrow right. The result was the 125. Hit enter, and it gives me that exponent of a 3.
Mr. Rathon, could you go over that if I've got an older calculator? I know you did that in the previous lesson, but I've forgotten.
Okay, so
I've got an 83.
Yours don't have the log base on it then,
I don't
right?
have the log base.
Okay, so what you got to
Right.
do, you got the log button on the very front of it, so we're going to utilize that. So what you would have to do if you don't have the log base, you would have to take the log of the result, which is the log of 125, and divide that by the log of the base, which was 5. Okay, so it's always the result on top. And I always remembered that because it was higher than the 5 was. So since it's sort of up higher, I knew it went on top, and then the base went on bottom. So follow me through. I'm going to hit my log on the front of it by the 7 here. I'm going to punch into 125. Okay. And then you got to close those parentheses and then divide, get the log again, put in the 5, close those parentheses. So it's just a little bit longer, but notice once I hit enter, I still get a 3 for that, okay? Now what's sad, if you brought that calculator on campus to me, I could have upgraded it and it would have had the same things mine had. But they sort of shutting that down.
No, it's one been sitting around from my kids in high school.
Yeah, is it like an 83 or is it an 84?
Yeah, TI 83.
Yeah, it'll do everything. Mine does, except it don't have some of them quick buttons for like the logs and stuff. So you can work around that though. So okay. Here we got a log base 6 of 36. So Carol, you would do a log 36, close the parentheses, divided by log 6, hit enter and be done. So this is telling me that 6 to some exponent is going to equal 36. You know what, if I do what, 6 times 6, I already got 36. So the exponent that would raise 6 to a 36 would be a 2. Now, some of these won't be too bad. Y'all can figure them out by your head. But we tune it up sometimes here. How about this? Log base 10 of a 10. So what exponent would I raise a 10 to turn it into a 10? And that would be a 1. So here's a little rule on this. A log base A, result A, if this base matches that result every time, that's going to equal 1 every time, okay? So no matter what's here, if that base matches that result, that answer has to be a 1. So let me tell you about this calculator. You see that log on the front of that? The log on the calculator is a log base 10 logarithm. So anytime there's not a number shown, it's automatically a 10 when it deals with logarithms. So that log on here would be a base 10. So you could use it for this problem because that's a base 10. So you could just put in log of 10 and hit enter, and it's going to give us 1. So this log on the front of that calculator automatically has a 10 by it, okay? Alrighty, so now this would be like number 7 for y'all. So now I'm going to turn it up because it's easy to figure out 5 times 5 times 5 is 125 and stuff. But what about a log base 3 of 1 over 81? So watch me do this by hand. So I got a 1 over 81 here. First of all, what I want to try to do to this problem is rewrite this 81 as a number that I can get using a 3 as the base. So we're going to rewrite 1 over 81 as 1 over 3 to some exponent. So let's figure out how many times we got to multiply 3 to get an 81. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So since I did that 4 times, the 81 rewrites as a 3 to the 4th. So y'all watch this. I don't want this to be a 1 over 3 to the 4th. I'm going to move this 3 up so it don't look like a fraction. So here's a question. If I move this 3 up to the top, what am I going to do to that exponent? Do y'all remember? So
Does it
watch
become
this.
a fraction?
Oh, you're on sort of the right case, but what's going to happen when I move these exponents up, I change their sign.
Oh.
And that's the only thing we changed is the sign of the exponent. So if you notice, this negative exponent in disguise is a fraction. Okay? Y'all remember doing scientific notation? When you did scientific notation, if you had positive exponents, you had real big numbers. And if you had negative exponents, you usually had decimals like 0.000 something. Sort of the same principle, but just remember, if I move an exponent up or down, I change its sign. So like this one was a negative exponent. If I wanted to change it to positive, I would put it on the bottom and it would look like this again. So here's the question. What's the answer to this problem? Because what did that exponent end up being?
-4.
That -4. Now, if you had log base on here, you can go down to log base, enter, and then we put a 3, and then you would go over and put 1 divided by 81. Once you did that, it's going to spit out a -4. Carol, what you would do is log 1 divided by 81 in parentheses, and then divide that by the log of your 3, and when you hit enter, you're still going to get a -4.
Yep.
And really, that's the main thing they're going to do, is just try to change up so that you can get negative exponents on some of these. Some of these I will get fractional exponents, but I'll show you when I hit them, okay? So now we got ln of 1. So let me explain what the ln is. Now, y'all, here's the thing. When you punch this on MATLAB, that's not a capital I, that is a L. LN for natural log, okay? So this is the natural log. And it's really a log base E. So that E was what we did the last class. That's Euler's number. And they use it when we're playing with these natural logs, okay? So this is a LN of 1. This is really a log base E of 1. So here's the question. What exponent would I raise E to turn it into a 1? And actually, there'll be a rule about that. No matter what the base is, if that result is a 1, the only exponent that can turn anything into a 1, y'all remember?
Is a 1?
So,
A 1?
well, watch this. If you did E,
0.
oh, you just said it, 0. So anything to the 0 power equals 1. So if this result is a 1, this is automatically a 0. But y'all can punch that in because you got an E, remember, right by the division sign here. So Carol, you would do log, whoops, I want the 1 first. Log 1 divided by log E, which is second divide. When you hit enter, that's going to give us a 0. So they're not too bad. I think these, since these are exponents, they're going to bring back a lot of exponent rules. Log of 1/10, anybody can do this one on the front of their calculator because there's not a base here. And we understand that base to be a 10 when there's not one written, right? So basically, you got a 1/10. What exponent's by that 10 at the moment? Since you don't see one, that's definitely a 1. So y'all, I'm going to bring that 10 up like I did that 81 while ago. But if I bring that 10 up, what's my new exponent?
-1.
1. So that means my answer over here is
-1.
-1. All right, let me throw a curve here. How about this? Log base 3 of 3 to the 4th power. What exponent would I put by that 3 to turn it into a 3 to the 4th? So I'm going to show y'all another little property. If this base matches the base of your result, then the answer is going to be whatever that B is. So if I got a 3 and I want it to look like 3 to the 4th, then I would raise the 3 to an exponent of 4. That makes sense, right? 3 to the 4th will equal 3 to the 4th. So base matches the base of the result. When they write it as a exponent, then the answer is automatically that exponent. And y'all, we can do that on here. Log 3 exponent 4. And then let me arrow down and close those parentheses. Divided by log 3, because that was my base. That's going to give us 4 every time, okay? All right, log base 5 of the cube root of 5. So what will help you in this section is if you can rewrite that radical as a fractional exponent. So let me give y'all some memories from those. So I got a radical with a root of n. Underneath, I got a with an exponent. Now, if there ain't an exponent there, it's automatically a 1 by this number, okay? So to write a radical as a fractional exponent, you take the base, which was a, you take the exponent, which was m, and you divide by the index of the radical, which is n. So remember two things. If there's not a number by the a, it's a 1 automatically. If there's not a number in that notch, then it's automatically a 2. So a square root is the only root that don't have a number there, okay? But I got a number here of 3. Okay, question? All right. So we got a number here of a 3, but we don't have an exponent by the 5. So the exponent by the 5 would definitely be a 1. So I'm going to write this without the radical. So I'm going to have a log base 5 of 5 to the 1/3. So that radical was rewritten as an exponent of a 1/3. But y'all look what I got now. I got a base that matches the base of my result. And anytime that base matched the base of that result, the answer was always the exponent of 1/3. So to turn a 5 into a cube root of 5, you take a cube root, which is written as a 1/3 on your calculator. So if you ever wanted to take cube roots of numbers, you could always raise them to a 1/3 exponent, and it'll give you the same answer. So y'all see how I did that radical, right? It's always the exponent over the root. And I always remembered that because I knew that tree roots were to the bottom of my tree, right? All right, what's this going to equal? Log 10 to the -4. Because remember, there's not a base here, so y'all know that that base is automatically a 10. And they're trying to get you used to that about that log. If it don't have a number, it's automatically a 10. So I got a base 10 that matches the base of that result. So the answer is automatically going to be that exponent of a -4. I would raise this 10 to an exponent of -4 to make it look like my result of 10 to a -4. Some of these ain't bad, y'all, and then some of them, they're going to try to get tricky on you. Log base 8 of a 2. So I got an 8 sitting over here. What in the world could I do to an 8 to turn that into a 2? So this one, you better be thinking radicals. Because anytime that result is smaller than that base, you're taking some kind of root. But it's not a square root because the square root of 8 ain't no 2. So let's think, how many times will we multiply 2 times itself to make it an 8? So that would be 3. What? That'd be 3. So that means to turn the 8 back into a 2, you would have to take a cube root of that 8. So cube root of 8 equals 2, right? But I'm wondering, how would I write the exponent from that radical?
1/3.
Would y'all just say
1/3.
1/3?
1/3.
There you go, because you remember there was a 1 by the 8. Which means that my answer is going to be that exponent of 1/3. Are y'all noticing every time you got these radicals, you're going to get fractional exponents? And this one had it in radical form. This one, they told you a curveball, but remember, the only way to go from a base to a smaller number, you got to take roots of it, okay? All right, I'm going to get a tough one here. Log base 23 of 1. So what exponent did y'all say I would raise 23 to turn it into a 1? That's always going to be 0. Okay, and then y'all can push that in, but remember, if there's a 1 there, we had that principle I showed y'all a while ago. Log base A of A equaled what? No matter, log base A of 1 equaled 0, okay? All right, moving on. How about this? Ln of E to the -3rd. So if you remember, and I told you Ln was a log base E, and then we got our E to the -3rd. Well, here we go. My base matches the base of that result. Anytime that base matched, my answer was automatically that exponent of a -3. So I'll tell you what they're doing. They're going to play with the logs and the LNs and try to go back and forth, because they want y'all to get used to the fact that this LN is the natural log and it's a base E logarithm, okay? How about Ln? 5th root of E. So let me rewrite this. I know that the Ln is a log base E. I know I can rewrite this 5th root of E as a fractional exponent. So that'll be E to the, what y'all putting there?
1/5.
So E to the 1/5. So I'm going to replace that over here, E to the 1/5. All right, so here we go. The base matches the base of the result. So the answer, once again,
1/5.
is at 1/5. Good job. All right, oops, let me change the, so these examples want me to convert to a logarithmic equation. So let me show you what I'm going to go by that. That very first thing I showed you when I had log x of y equals b if and only if x to the b equals y. This side, this equation is called logarithmic. This equation on this side is called exponential. So exponentials are written with exponents, logarithmic are written with the logs, okay? So On number 17, they got 10 to the fourth equals 10,000. So they want me to rewrite it from this exponential form into the logarithmic form. So to do that, I need to put my log. I need to figure out my base. Well, my base is the x. When it's in exponential form, the base is the number being raised to the exponent. So there's my base, 10. So I'm going to bring down my 10. But remember, if I was writing this on MATLAB, I wouldn't have to put the 10 because it would be understood that that 10 would be there, okay? All right, B is the result. Y is the result. So that's what it all equals. So your result is going to be the 10,000. And that's going to equal the exponent. So the exponent was B. So that's what mine's going to equal when I'm done. And the exponent is a 4. Now, check yourself and make sure you got this in the right order. All you got to do is punch in log 10,000. And y'all, I better get a 4 when I do that, okay? So that's how I check myself real quick. All right, 18 is 243 to the 1/5 equals 3. So here we go. We got our log. The base is the 243. So that's going to be the small number down here. The result is the 3. And we know that because if we start with a bigger number than our result, then we knew we had to take some kind of roots. And the exponent of 1/5 means they took the 5th root of that 243 to turn it into a 3. So on that one, Carol would do log 3 divided by log 243 to get to 1/5. If you got a newer calculator, you'll just punch down to your log base and then put in your 243, arrow over, put in a 3. I'm going to get a 0.2, but remember 0.2 in math form is 1/5. So if you want to check to see if you're right when you rewrite them, just do that real quick, okay? E to the 5 equals R. So now they're just going to throw anything at you just to see if you can rewrite them correctly. So I'm going to bring down my log. My base is the E. My result is the R. And that's going to equal the exponent of a 5. Now, it will take this answer, or I can replace the log E with a ln, so that this could be the ln of R equals 5. Okay, so it takes it either way on these. ln can be written with the log base E, or you can just use the ln, okay? All right, so the last one of those has a P to the K equals 81. You see they get more and more letters and try to confuse you more as you're going. But my base for my logarithm is the base,
Yes.
which is that P. The result is the 81. And that's going to equal the exponent of K. So they're going to start out, like I said, pretty nice with numbers. And then they're getting some of these. There's no way I can check that. Log base P, because my calculator, if I put a P in it, would think it's some kind of number. So, all right, that we converted to logarithmic. Now they want us to convert to exponential. So this one has, this is like 21. Log base 5 of 125 equals 3. So you're going to start with your base, which is the 5. You're going to raise it to the exponent, which is the 3. So 5 to the third power is going to equal 125. And to check them, you can just punch in 5 exponent 3, and it'll kick out a 125 for you, okay? Log of a 0.1 equals -1. And remember, 0.1 is really a 1/10. So since you got 1 over 10, that's how you get that negative exponent, because when you pull that 10 up, that positive 1 becomes a -1. So let's see what we do. There's no base, so automatically that base is a 10. Your exponent is a -1, and your result is a 0.1. And I'm pretty sure if you did 10 exponent -1, it's going to give you 0.1, which is our answer. All right, so I'm going to do 24. 23 was just like that one. 24 I wanted to do because it's a bunch of letters. Log m of t equals -y. All right, so your base is the m. Exponent, whoops. Exponent is at -y. And then that's going to equal t. There you go. Now, y'all watch out. MATLAB, but they use capital T's and little m's on the answers. You got to use the capital T's and little m's. That thing's a little picky. All right, next, we're going to use a calculator. To find the common logs.
Can't see it.
Okay, I gotta go back up. To find a common logarithm. Now the common logarithm means it's just a log base 10, okay? And then the other one I said was the natural log. So they're just wanting to get good on the calculator doing the logs. So log of 64, and they're wanting you to use the log on front of your calculator now. So you got a log button, so put in log, punch in 64. Now, we're going to round these to 4 decimal places. So 4 decimal places. So we punch in log 64, because I'm raising 10 to some exponent to get 64. So 10 to the first is 10. 10 squared would be 100. So since 64 is in between 10 and 100, the exponent has to be in between a 1 and a 2. Okay? So this rounding out to 4, I'm going to go to 1.806. Looks like that 1's going to turn into a 2. All right, y'all, same thing on log 2. So 2 is smaller than a 10, so 10 to 1 would be 10 already. So since you're trying to turn it into a 2, that exponent better be less than 1. So here we go, log, punch in a 2 and enter. I'm going to get a 0.301. So that's a 2 after the 0, so that's going to stay as 0. Log of negative 36. So punch that in and see what I get. There's my log. Then y'all are punching in that negative 36, right?
Mhm. Gives me an error.
Oh. Dang, I'm getting an error too. So you're telling me there's nothing I can do to a 10 to turn that into a negative 36. That makes sense. There's nothing I can put here for an exponent that'll turn a 10 into a negative number, right?
Mm-hmm.
So this basically is what we call does not exist. And if you converted your calculator into imaginary numbers, you would get imaginary answers. But those don't exist in the real world. So that's why up here it's saying what? Non-real answer. Okay. And when you hit enter or go to, that number 2 says go to, it's blinking on them parentheses because you got a negative 36 in there and it can't take the log of a negative number. So anytime you try to take a log of a negative, you might as well put does not exist, because I can't turn positive numbers into negative numbers by exponents. All right, y'all, then they wanted y'all to get good using the LN, so find the LN of 53. And we got an LN key on the front of our calculator by the 4. So let me clear that bad one off. So LN, what am I doing, 53? So that's going to be what, a 3.970. That's, because that's a 9 after that, so make that a 3.
3.
All right, 29 is the same, but I wanted to hit this one. LN of a negative 1.19. So remember, LN is a base E. So can you turn the E into a negative 1.19 with an exponent? And hopefully on your calculator for a negative 1.19, you're going to get the same answer. So that means this one does not exist. So you cannot take a log or a natural log of a negative number. All right, y'all, so ending this up toward the end, they want you to find a log using change of base, change of base formula. So let me see what I got. I got a log base 6 of 18. So guess what? Change of base formula is what I was telling Carol to do in the beginning. Now, if you got the log base in your calculator, use that for this problem. Okay? But change of base would be doing the log of 18 over the log of 6. So these problems went back before they updated those calculators and added that log base in them. So this was before that time. What we had to do was actually do the change of base, where we took the log of the top one and divided by the log of the bottom one. So when y'all do that, let's see. Now remember, if you got the log base, you'll just click map and go down to your log base, enter, put in a 6, and then what's that, an 18?
Yes.
And then if you did log of 18 divided by log 6, you're still going to get that same answer. That looks like what, a 1.61 3, and then that looks like that's going to stay a 1.
1.
Okay. So I'll let y'all try this one. Log 3 of 70. So what y'all get?
3.8671.
Now, I'll be happy with that because I know 3 to the third is 27. 3 to the fourth power is 81. So it had to be in between 3 and 4. So good job. All right. So let me go back and show you how I would graph some of these like in question 1 and stuff. So I'm going to graph y equals log base 3 of x. So y equals, I'm going to clear that out. If you got log base function, you would use log base at this point. So go to math, go down and find your log base, hit enter. You would put a 3 in and an x. So Carol, for you, we're going to clear that out. We're going to do change of base. So Carol, you would do the log of x, close those parentheses, divided by the log of 3. Okay, so Carol is doing log of x divided by log of 3. And then if you got the log base, you're using it that way. So we just want to hit graph. Whoops, let me fix my window. So to fix my window, I hit zoom 6. And if you notice, it's just a little graph. Looks like it's coming right up and just shooting over. Okay. And that makes sense. For a 3 to turn into a 1, the exponent has to be negative. When x is 2, for 3 to turn into a 2, the exponent's still negative. But when you get a 0 here, where am I crossing? Yeah. And then to turn into a 3, that would be a 1. And then it's going to keep going slightly bigger as it goes out. But you can hit that graph in that table and look at what's happening when these x's are negative. We're getting errors because we can't turn numbers into negative numbers. So any negative x's are going to make that an error. When x is 1, the exponent had to be 0 to make that a 1. So you're getting that 0 right there. And then you're seeing it increases slowly. That's why it's sort of almost flat looking, but it's still growing. It just grows slower. But when I hit numbers like 9, 9 is a perfect square of 3, so you get an exponent of 2. The next perfect exponent I would have is going to happen at 27, because 9 times 3 would be 27. And there's my 3 at 27. Any number in between 9 and 27 is going to have a 2-point something exponent. And then you start at 27, exponent is 3. Anything in between 27 and 81 will have an exponent of 3 point something. Okay? So that's what you'll do. I just wanted to, excuse me?
I didn't get the, when I put the log x divided by log 3, the graph I got is like a straight line going across.
Oh,
at
see,
about
that's
2.
what I did. Okay, so look at mine right here. You see I got my log. I'm going to clear it out and do it. Let's do it again together. All right, so we're going to hit our log. grab that X, close those parentheses. And then divide, grab that log again,
Okay.
and put in that 3. Close those parentheses. Okay, let me hit graph.
And then
So,
graph.
hit graph. Is it looking like what I
Yeah,
got
I'm
on
still
my?
getting a straight line.
Hey, do this. Hit zoom in the middle, hit zoom, and hit number 6 for standard.
And then enter.
Uh-huh.
It's still going straight across
Huh.
at 2.
At the 2, it's going straight across. So that's telling me, let's see, do this one more time. Hit zoom, and it shows a long list, and then punch 6. And it should automatically start drawing it.
It's, oh gosh, I'm still getting the same thing.
Let me think.
Log X parentheses divided by log parentheses 3, close parentheses, and then I hit graph, and I just get the line all the way across at 2,
Okay,
horizontal.
so hit second graph and pull up that table. So you got your X values?
And it's got everything Y at 2.
So all your Y's are showing 2? Carol?
Yes, showing 2.
Okay, so go back to Y equals. Sounds like is there any other equations in there? Arrow down and see if there's anything else that's in your calculator down there. Just go through all them Y's real quick.
And you know, Y1, 2, 3, they're all cleared out now.
They're all clear.
Okay, so I should put this log thing should be next to the Y1 equals.
Uh-huh.
Oh my gosh, I wasn't even on the right screen.
Oh, okay.
I just hit the log button.
Oh, no.
Oh my gosh.
Hey, wait. Okay, I see what you're doing.
It's Y1, then log X divided by log 3.
Yeah.
Okay.
Because whatever, you must have had something equal to a 2 in there or something earlier. I think we're on the right track now. So punch that in, and then I'll show you what my graph looks like.
All right now.
Okay.
I'm sorry. I wasn't putting it in Y1. I was just doing what you had written there, log X divided by log 3.
Okay.
Okay.
So
now my graph looks like
so that
yours.
means your calculator thinks your X's are 9 in it. So if you hit X and enter, see what it does.
Just like clear this out?
No. Just hit X.
Or just put X?
And then hit enter.
It says 20.959.
Yeah, that's what I was thinking. It was something close to that. All righty, so here's the thing. If these logs.
So when it says graph, that means I have to put that in the Y1.
Yes.
Okay.
Okay. And then on your homework, they'll have little graphs, and you'll just pick which one that was. Like that one, I would have went with C on it, because that little graph does like that. So they'll just have y'all picking one of those graphs.
Okay. Do that out.
All right, so that's the world of logarithms. Just remember, logarithms ain't nothing but exponents. Okay? So when you do a logarithm to a number, You're just finding what exponent that number was raised to get that result. So next class, we're going to go over logarithmic properties, like properties of exponents. So there'll be about 4 or 5 properties we go through, and it'll be getting us ready to solve the equations in 9-6. So 9-5, we learn properties. 9-6, we solve equations. And then 9-7, we sort of go through exponential growth and decay type problems. Okay, so we're getting close.
Okay, so for this week, we have 9, 3, 4, and 5.
No, don't worry about 9-5. 9-5, I'm going to do Monday. So what I'll do
Okay.
Friday, I'm just going to catch up everybody from 9-3 and 9-4. Next week, I'm going to do 9-5 and 9-6. After Thanksgiving, I'll finish up at 9-7. Y'all have test 4, and then we'll be reviewing for the final for ever how many days is left. I found out that y'all's finals are, let me see, they're on the 14th and 15th. So our class, our final will be December 14th. So what I'll do is I'll open it probably around the 6th or 7th. No, let me see. I'll probably open it the 7th or 8th, which is the week ahead. Review and stuff, but if any of y'all take it early, you can, and it'll be due by the 14th.
Does that go for me as well, since I'm an online student?
Yeah.
I'm not the Monday. Okay.
Yeah. So I'll probably make everybody's either the 14th or 15th. I'm probably going to go, I might just make everybody's the 15th. That's that last Tuesday, since all y'all are taking them online anyway. Okay. So Friday, I've got all my stuff at home now, so Fridays will go smooth. If y'all get on and need any homework help, I'll be here on Friday, okay?
Thank you.
All righty, so if not, I'll see y'all next Monday, okay? So I'm gonna stop.
Thank you. Bye-bye.
All righty, y'all have a good weekend.
Bye.
So I have a question. I'm sorry.
Oh, okay, hold on, okay, I'm here.
Okay, are you going